The Caesar cipher is a substitution technique invented by Julius Caesar, which replaces each letter of the alphabet by a letter which is 3 letters down from it. So A would be replaced by D, B by E, and so on. The alphabet, which basically forms the set of all options, is wrapped around so that the letter following Z or Z is A, allowing us to compute the substitution as previously described. If we assign numbers 0 to 25 to the letters of the alphabet, we can define the Caesar cipher using the following formula, where C is the ciphertext, E is the encryption function, P is the plaintext, and mod is the modulus operator. We can modify the cipher to shift the substitution by any number. To describe a shift of some number k, the formula would be C equals E kp p plus k mod 26. So this is the same as what we had previously, but the 3 shifts have now been converted into k shifts, and k can be any number between 1 and 25 inclusive. The decryption of a Caesar cipher involves moving back by the number of shifts specified in the encryption process. So if A is substituted by D, then to take D back to A, we just have to move backwards in the opposite direction, applying the same number of shifts. And the formula for the decryption process will be P equals to D kc c minus k mod 26, and the only difference here is that we are going back, so that's why we have the negative, and the D is the decryption function. So let's look at an example. If our plaintext is please and thank you, our ciphertext for Caesar cipher with 3 shifts would be the following. Getting the plaintext back, and our plaintext is please and thank you, from this text would require us to go backwards, so we'd step through each of these. So you'd go to S, then go 3 back from S's position in the alphabet to find P, and you do the same for all the others until you have your please and thank you back. As you might have seen, this is not secure because if we know the number of shifts which were applied, we can easily turn the encryption or the encrypted text back into the plain text, and we haven't really hidden or achieved what we're trying to do. So the point of encryption is to hide text, but if you can easily figure these things out, then it's not so secure. In the next video, I'll show you how to implement this algorithm using the Python programming language, and we'll also cover a few algorithms after that which are a bit more secure than this. So if you have any questions, leave them in the comment box. If you have any comments, anything, let me know in the comment box. Like, share, subscribe. I'll see you in the next video.